That's all right. Okay. Hi, everyone. Welcome to the Intarea working group. No, thank you very much, Mike. Excellent. So my name is Juan Carlos Zúñiga with Sigfox. Wasim couldn't make it to this meeting, so he's probably going to join us remotely, but he's been helping a lot from the background, so he's still around. Note well, reminder, as you all probably know by now, but she's still be reminded. So there are the IEEE policies. Yes. Oh. Thanks for that. Yeah, so blue sheet's about to load around. Thanks, Rutger. And so please make sure that you are familiar with the note well and the obligations, responsibilities that this entitles to. As a reminder, minutes are taken. The meeting is being recorded. Your presence is logged. Describe, thanks a lot, Ian, for taking care of that, as well as the jobber, Michael. And our agenda has been slightly updated. There were a few last-minute changes, so this is what it looks like now. We're going to have the update from the chair slide. Then Eric is going to present the provisioning domains, IP fragmentation considered fragile from Bron, GUI from Tom, remotely, then the limited domains from Bing, IP protocols mounts, overlay path segment from Yizu, and the socks from Vlad. So this was a light minute submission that fortunately made it into the agenda because we had a drop-off. That's the main change. But please, when we send the request for presentations, make sure that you send them on time, because otherwise it's hard to play with the agenda and make sure that we can accommodate everyone. All right. So is there any bashing to the agenda, as you see? Perfect. If not, let's go back. And next is Eric.
Thank you. So a refresh, or rather an update on the -03. So my name is Eric Vink, presenting for the authors. What has changed since IETF 102 is basically that I was able to present the complete protocol and the complete draft to V6 Ops, because of course they got an impact there. It was well received. It also now the draft referenced by 2 other drafts at least. I mean, I don't know all of them, of course. So it proved the interest of it. And the release, the -03. Change in -03, we made 2 main changes. One is a clarification when we need to send a large PVD option in multiple arrays by sending piece by piece. That's allowed, and we simply clarify it and explicit exactly what to do. Eric Klein also suggested to make some change into the part connection sharing by the host, so for tethering, and the like. It was 3 lines before, what a bit small, to be honest. So we tried to expand it. So there's a major change in the -03. We didn't change anything in the protocol, packet format, or whatever. And the text really like this. I send it to the list because I think that's really important for us to reach a consensus and go to working group last call. It basically says, when we receive from, let's say, the 3GPP interface, an array containing the PVD-ID option, then it's up to the choice of the phone operator, being a guy or being an operating system or whatever, to push down the same PVD. And we specify that we should as well do it, keeping, of course, the same fully qualified domain name. This is how we go and fetch the JSON. This is how an application can select a specific PVD. Of course, if it's receiving multiple PVDs on the 3GPP, it can also forward the multiple PVD below. HBit, that's the one that triggers, remember, the SSL TLS connection to fetch a JSON file. If you have it from the 3GPP interface, it does make sense that the other people below you, after you, are doing the same thing. Delay and sequence number, if you remember, this was the change of the DAF02. This is how we refresh or we push a refresh of all the JSON file. The L bit, it stands for legacy. This is basically whether the PVD and the JSON file associated to it is also applicable to the IPv4 address that you receive by the HTTP, as long as the V6 router and the V4 router are the same. I put it in blue because I'm not sure, I don't see it, but Ted Lemon says something is a little bit fuzzy there. And the bit for the reserve field must be 0, simply. And now we say the value of the R bit. The R bit is basically whether inside the PVD ID option itself, you repeat the complete router advertisement header for a few things like MTU, for instance. So we say, hey, if the R bit is set on the 3GPP, so meaning that the PVD ID contains a copy, a different copy of the array header, you do the same thing below, which I think does make sense. Now, whether the sentence in blue is fuzzy, as well as whether the connectivity should be shared only by PVD-aware host or not. When Pierre and myself were writing this sentence, in our mind, it was crystal clear. But obviously, it's not. Okay? So, and I fully agree with Ted Lemon and Alexandre Petrescu on this one. We need to review it, and we wanted to make it in one sentence, but I'm afraid that we need to consider a lot of cases and enumerate them. Do we receive IPv4 connectivity from the 3GPP, for instance? Do we need to share the IPv4 connectivity? Do we receive one PVD, multiple PVD? Do we want to push the PVD below? And in all those cases, we will say recommendation. So this is still on our plate there. And I hope to get some assistance from the list to cut out all those cases. So now basically we went from 3 sentences on this part on -02. We are about 15 sentences on -03. We will end up with 1 page on -04. Or we simply consider, I mean, if we cannot resolve it in the -04, I tend to say TBD, okay, in another draft or whatever, but then it's annoying because I really want to push this. So next step, issue a -04. One minor change, one author exchange of companies, so we need to clarify this and put this extension to most probably 1 page of text. Review by 6 months, I think, is mandatory. I was unable to be on the agenda, partly my fault for asking late. This morning, I get a side meeting that was announced on the 6-month mailing list. We were 2 in the room, so I don't consider this as a real review. Even if the non-face here that are interested in the draft are also in 6 months in V6 up, so that's not a big surprise. I don't expect anything bad or good from the 6-month presentation and review, because they're the same people that will do the review there that are here, and they are in the V6 ups. So hope to do this and then go to working group last call at spring at the latest. And that's it for me.
Ian Farrer, just a small point while you're clearing things up. You've added a reference to 3633 in version 03. That's going to be obsoleted when 3315 BIS gets presented. Okay. So I think most things are referencing the BIS now.
Okay, so I'm in a 3rd point for the revision of -04. Thank you. Okay, thank you.
Thanks, Eric. That's cool. Yes, you're fine.
Okay, Ron Bonica, IP fragmentation considered fragile. The draft has been around for about a year. It's had so much conversation on the list that I'm afraid that we're going to use up all the bits on the internet. Next slide.
Oh, thank you.
Okay, after a little conversation with Tom Herbert, I think I can describe the problem and the recommendation while standing on one foot. And just in case I couldn't do that, I studied yoga for a while, so I can stand on one foot for a long time. Anyhow, the problem is when a packet is fragmented, the upper layer header appears only in the first fragment. Many stateless middle boxes, firewalls, load balancers, and the like, require access to the upper layer header. Now, by definition, a stateless middle box doesn't perform virtual reassembly. Anyhow, fragmented packets cause these stateful middle boxes to behave badly. So what do? Well, we have a two-part recommendation. One part of the recommendation is for application developers. New applications should break their reliance on IP fragmentation. What we want them to do is push the problem of fragmentation up to the upper layer, so you won't see IP fragmentation that much anymore. We realize it's not always possible. So there's a part 2 of the recommendation. Middle box developers should make their middle boxes stateful enough that they won't break in the presence of fragmented packets. Now, we should probably visit, whether we think either of those recommendations will be heeded. We'll talk about that in a bit. Yes?
You should finish. I'll ask.
Okay, outstanding issues. I think there is only one outstanding issue, and that's about, we have section 6 that talks about applications that rely on fragmentation today. The poster child is DNS, and especially with DNSSEC. There's an outstanding comment that iPerf should be in that list of examples, and we've had pushback in either direction. Since it's only in examples, I think the right thing to do is leave it out, since it's really kind of not the main point of the document, it's just examples. Also, if there are any other outstanding issues that I haven't gleaned from that very long list on the conversation on the email list, please bring them out here. There's also a merciless reality check. Will applications heed the recommendations of this draft? Well, the cost of compliance for new applications is probably relatively low. Hopefully they will heed the recommendation. As for others, if they're economically motivated, yes, they will heed the recommendation. If they're not economically motivated, their behavior is predictable. The same question applies for middle box developers. Will they heed the recommendation? Well, the cost of compliance depends on the middle box type. Probably ASICs-based middle boxes will be a little more difficult to comply. Also, there's the problem of installed base. So the ultimate answer to both of these questions is the market will decide. We make a recommendation. People with lots of money actually decide what happens. So the next steps is I'd like to make one final update depending on the outcome of today's conversation, and then go to working group last call. David Black, what's your name?
David Black. I'm from transport area, and I'm not sure whether I'm here to help you. Over in transport area working group, we're working on this interesting mechanism called UDP options. And one of the things it could be used for is fragmenting UDP packets at the UDP level. Now, in discussion of it in TSUWG this morning, I think we were a little uncertain about the value and likely utilization of this. In light of what you have to say here, which basically is I'm hearing as almost a ringing recommendation from Intarea to stop using IP fragmentation. I'd be interested in views from this community on the potential value of UDP options for UDP level fragmentation as a tool to get there from here.
UDP fragmentation solves my problem because the UDP header would appear in every UDP fragment. So I'm jumping up and down and cheering.
I believe it does.
Michael Abrahamson. So I think I support these conclusions. I think this is as close as we're going to get to, recommendation coming out of this. It's a pragmatic approach, and I think for transport is there are these stateless boxes. It's very efficient to do stateless things. So please include in every packet what these stateless devices need to make a decision on what to do. So that going forward. So saying fragmentation, the problem is not IP fragmentation per se, is that the decision information is not in every packet. So the recommendation should be all decision information should be in every packet, whatever you do.
Yes, that's the recommendation to application developers.
Right.
But knowing full well, some application developers won't heed the recommendation.
Right.
If you're a middle box developer, be aware of that.
Yes.
Do what you have to.
So I was supportive of saying that these middle box devices, that there should be a must in there and support fragmentation. But I know that we don't have a protocol police anyway, so it doesn't matter. So, but I think this is a reasonable. It reflects reality, and it's a sensible recommendation on everything.
Thank you. Fred. What's
Fred
your name,
Baker.
Fred?
My name, I think, is Fred Baker. I'm not sure that UDP fragmentation solves your problem. It certainly enables you to fragment a packet. It doesn't address TCP. It doesn't address OSPF. It doesn't address, I can think of a list of things that it might not address.
Oh, clearly, UDP fragmentation is only going to help you when the transport layer is UDP. It's not going to help you all the time.
And it's only going to help you when you know end-to-end what the path MTU is. If you don't know yet what the path MTU is, then the network device isn't going to do it for you.
Well, that's also true, but IP fragmentation won't help you unless you know what the path MTU is.
IP fragmentation, well, IPv4 fragmentation actually does.
Oh, yeah.
But,
Okay, you're
yeah,
right.
Okay. So, okay.
Yeah, Suresh Krishnan. So, couple of things. So, one of them is like kind of, we somehow need a way to expose the path MTU to the upper layers, right? So, this is not like something that's, it's just a specification here. Like there's an interface that's missing here where like some application discovers what the path MTU is from the IP side. So, I think that needs to get specified somewhere. And since we decided, yeah, whole sentence. Oh, awesome. Very good. Okay, done. Okay. Like, but
It's the best sentence I ever wrote. What was it?
no, but like seriously, right? Like without like some socket option or something, which we don't specify here, I don't know, like, how that's going to happen. So I think it's all dandy that we write this up, but at some point we have to see how this can actually be implemented. That's one thing. And the second thing is like, in the pathological case, this like you're still gonna see the fragments happening, right? Even if like you expose it somewhere, say something changes along the path, you still need to be able to handle. So I'm just wondering, so like seeing the two recommendations, like I'm happier with the second one than the first one, right? At some point, and transport can make a decision independently whether they need to do it, like they did with PMTUD. So like PMTUD, right? So I would think the first recommendation is like, since like David brought this up, right? I would think it's like a decision for transport to make whether they want to try to do this rather than a recommendation from in that transport should do it. That's what I think, but I'm open to recommendations.
I'm just going to get quickly in the queue. I agree, and from what I'm hearing, you have to care about the infrastructure guy. You have to care about the application. But also the protocol developer potentially, in which case may be transport or someone else. I think that these are your three customers of this.
And it's kind of a strange invocation of Postel's law. Be conservative in what you send and liberal in what you accept. So since we know that there's this sensitive area, IP fragmentation, don't get into it if you don't have to, if you're an application developer. And if you're a middle box developer, deal with it if the application developer didn't stay away.
Okay.
Eric Klein. Just wanted to observe, I think, or ask you about section 7.4, recommendations for network operators. Is it worth, it just basically says be standards compliant, meaning, make B2B should work. Is it worth a one-line sentence saying that operators should make sure the MTUs on their links are fit for purpose, whatever that purpose may be?
Sure. If you could send me a reminder, I'll put it in the next version.
Okay.
Michael Evans, I just wanted to comment here that there are operating system vendors right now that do expose the path MTU to applications, so that the application developer, if he's sending a UDP packet, he can understand if this will be fragmented or not.
Mm-hmm.
So it would be good that, yeah. So I don't know if that should go into another document or something, but it's a good recommendation for operating system developers to including their UDP stacks.
I agree with both you and Krishnan, Suresh, about this. Maybe a good thing to do would be put in a one-liner saying such an interface should exist, and then in another document, figure out what the interface looks like.
Great.
Gorifer is trying to rapidly catch up as I walked in the room. Two things I heard which I'd like to just immediately comment on. I think that interface has to exist. The MPS thing has been maximum packet size passed up the transport has been discussed in TAPS. We have lots of thoughts about how to do it there. That needs to start appearing in other groups in the IETF and become real. It doesn't exist currently.
Actually, a question for probably for both you and Suresh is, what area should that interface live in? Int area, transport area?
Suresh Krishnan. So I think our answer until today has been not in the IETF. Okay, so like we haven't really. So like every time we had to, like we want to write something in socket over the past 10 years, we push back on it and say it doesn't belong to the IETF. Okay, like go to POSIX whatever to do it, right? But I think Dave Taylor, if he's in the room, he'll say some. Okay. So that's kind of been the answer. So like I think the last one we did was like probably 10 years ago, right? Like with a socket interface. And I think what they will say is like, we are fine to write like a non-concrete, like, did you have another name for it, Dave? Abstract interface is fine for us to define, but not like a real interface for somebody to use. So I'll leave it to Dave because he talks much better than me.
Thanks, Rish. So I think part of the question was, where does the discussion belong? And I think what we heard is right now that discussion is in TAPS. Separately, does the IETF do like abstract or concrete? And there's both things are interesting. For abstract things, I think TAPS is a good place for it. For concrete things, POSIX, W3C, pick the language, I'll tell you what the organization is a good place for it. Right now, the closest thing that we have to a liaison for POSIX is me. I'm on the mailing list for the C++11 group, which also does C stuff. And so if there's things that we want to say, let me know. I monitor the list. All they really talk about right now in that community is they're adopting basically the Boost style APIs, which is, wrappers over what already exists, not adding new functionality. And the only stuff that they're talking about really is how do we link that to new like async models for doing async IO and so on. If there are things that we want that community to do, I'm happy to post that to the list because it's a group that's hard to get into. It's basically invite only, and I'm the IETF representative, and there's at least, I think, 2 other IETF people that are on that list, not just me. But if there's things we want to say, I'm happy to convey that. But so far, I keep asking at each IETF, if there are things we want to convey? And so far, the answer is not yet, not yet, not yet. And I'm figuring someday the answer is yes, and I'm still here for you. So.
Gorifer has just run down from TAPS. We haven't done it so far, and there's 2 different sizes of MTU, and there's 2 different mechanisms running at the moment, because some people actually do have path MTU and black hole discovery code down below. We're going to have to be careful when we define this, that we don't have network layer making one decision and transport layer making another, and then an app on top trying to do probing. In TAPS, this is taking time to figure out how to do this, but they are going to try and figure out some guidance for the transport bit, and the network people probably have to figure out whether they need a separate API or whether they just simply exposed at the transport.
Well, remember, for the purpose of this document, all we need to do is say we need a solution. We don't have to define the solution here.
There you
In
go.
fact, we definitely shouldn't define the solution here.
And somebody mentioned UDP options doing reassembly while I was out of the room on fragmentation.
Yes, that was David Black.
Be scared about what you put in the socket layer of the stack, is all I say. I mean, if you don't want to do fragmentation reassembly at the IP layer, then don't do it at the socket layer either, I think. It
Okay.
really should be done in application space if you're really pushing up to the application, like a tunnel would do as an application.
This draft doesn't reference UDP fragmentation.
Thank
It
you.
says, please do it in the upper layer. It doesn't say how to do it in the upper layer.
Or even more thanks.
So I think the action item I have is there is a recommendation for a new interface that's Suresh suggested. If you can send me a one-liner reminder to put that in. And I think, David, you were the guy who had another, somebody had another one sentence that I should put in. And
David Black, it wasn't me. No, I got up to agree with Gory that not referencing UDP options for UDP fragmentation in this draft is the right decision.
right, and we don't.
Yes.
Suresh Krishnan. Tony, did you want to say something and you got timed out? Okay, cool.
Okay, so I will wait for those 2 emails and then update the draft, and then could we do a working group last call?
We should be, yeah. And otherwise, for the minutes, are
Okay.
usually pretty good. So
Okay, thanks a lot.
to catch up from there. Thanks. Thanks. So next is Tom.
Hello, can you hear me?
We can hear you loud and clear.
Okay, great. So I'm going to give a short update on generic UDP encapsulation. And this covers 4 drafts. So the first 2 are in working group last call, and then 2 new drafts that I'll describe briefly. Next slide, please. So the base GU draft, version 6, Fred Templin is doing the Shepherd write-up. Thank you for that, Fred. And then the extensions, which is also working group last call. We need a Shepherd for that, I believe. So I would ask the chairs to possibly assign that. Next slide, please. So this is a new draft. It's control messages for generic UDP encapsulation. So GU allows both data messages and control messages. Control messages are designed to kind of express control information between the tunnel endpoints. So the initial messages, there's 4 of those, a capabilities query and capabilities response. So these are messages to determine what a GU receiver can handle. So for instance, which flags or which security settings, what have you. So it exchanges basically parameter information. And then there's kind of the more typical echo request, echo reply. The echo request reply allows for timing, sequence numbers. Looks a lot like ICMP echo request reply. Next slide, please. So the capabilities are encoded in TLVs. And right now there's 4 TLVs that are used for this. So the GU variants is a simple bitmap. And right now there's up to 4 GU variants. So there's only 2 bits or 4 bits used in the bitmap. The control messages type, again, the data in the TLV is a bitmap. So this is a number, a bitmap between 0 and 256 bits. The GU flags just map the flags of the GU header. So if the flag is set in the data, that means the receiver supports that particular flag. Multi-bit flags are a little bit tricky in some sense, so they will hold the max value. We may need TLV for specific multi-bit flags if, for instance, it's a 3-bit flag and value 5 is supported but no other values, so we could have a TLV for that. And then the payload transform types, that's the last one. Again, that's a bitmap and that's a byte field. So it's a bitmap from 0 to 255. Next slide, please. The other draft is generic TCP encapsulation. This was actually inspired from a TSV working group discussion where we wanted to use tunnels over TCP in order to get through firewalls. So this would be layer 3, layer 4 encapsulation over TCP to get through a firewall. Say, for instance, this was an application when using UDP, and UDP was being blocked by the firewall. The idea would be, okay, just use that over TCP, and then you can get through the firewall. So in this case, we're encoding GU messages into the TCP stream. The one thing that we need is message demarcation. So the message length precedes each header. As I said, it can do layer 3, layer 4 encapsulation. If it is layer 4 encapsulation, the IP header for each message, each layer 4 message is derived from the outer header. So we can get the addresses and the rest of the fields from the outer header. The one caveat here for the layer 4 encapsulation is that if an encapsulated transport layer includes a checksum like a UDP or encapsulated TCP, and the outer packet goes through a NAT, the addresses are changed such that the checksum would be invalid. So the NAT address checksum option that we defined in GU actually should support or should solve that problem as long as that's set correctly. Next slide, please. So this is what the GTE, the GU transport encapsulation or generic transport encapsulation looks like. And as you can see, it's pretty straightforward. The message format is just preceded, a GU header is preceded by a length field, followed by the GU header, followed by the payload. The length is the complete message from the start of the length field to the end of the payload. And then on the right, these are simply sequentially placed in the packet, one message after another. Next slide, please. One thing we can do, since this is a TCP stream, is do some creative header compression, similar to Van Jacobson compression for PPP. And there's two variants right now that are allowed. So one is we can set the message length through a GU control message. And the idea is that the message length field could be 1, 2, 3, or 4 bytes. So if, for instance, we were just encapsulating UDP messages, they would have a maximum length of, or only 2 bytes would be needed to express the length. So we could set that to 2 and then.
Okay. So he thanks the audience in advance. Let's see if we can catch up with his connection. For the mythical people, if you're hearing, we lost Tom. Tom, can you still hear us? Okay. One more try. Okay. So then we were pretty much at the last slide. I recognize Gori at the line. So how about if we move to the next presentation and then we pick it up from here, or you want to make your comment and minute it anyway? Or was that a question or a comment?
It was going to be a question, but I can convert. Gori Fairhurst, as a TSVWG chair, I didn't quite get why this was being proposed. And I did notice the draft contained TSVWG in the title, and this is the sort of thing TSVWG does. So if this group thinks that's really cool, then please come and talk to TSVWG about it.
Okay.
Yeah, Suresh Krishnan's as responsibility here, right? So one of the things we kind of did when we took up GU was that, like, that would be like a one-off document. So Intarea doesn't really, take up like whole protocol suites, right? And now we had one, and then we had the second one, which is the extensions. Okay, now we're there's a camel is slightly putting its nose in, the face is in. And so if it becomes like a protocol suite, with whole bunch of extensions, I really don't think it belongs here. So we have to find a home for it. I don't think it's this. Okay. So if Gori wants to take it, happy to give it to you.
Gori wanted to be able to comment on it, on transport people similarly. Whether we need yet another version of an encapsulation depends upon the use case and the number of people who are implementing and the need for interoperability, et cetera, et cetera, et cetera. So we're going to chart this as a BOF. I've got lots of questions I want to ask about why we're doing it. I don't have a problem with GUE, but I do see a growing number of drafts here, and I see a growing expanse of the area that's covered.
Yeah, Suresh, again, so yeah, I agree, Corey, right? Like it's really, if there's a significant amount of work here, I would think like a BOF would be like a better way to go, and then figure out like, where it's going to end up after. So as I said, like, I don't think here is the right venue for this, because I think most of the review expertise is somewhere else. And so we can talk offline, I think, like probably over email with Tom as well, and then figure out where we go.
Okay, sounds good. Yeah, that was good feedback. And well, if ever Tom couldn't hear it, I'm sure it's going to be minuted and recorded, so that's good. We'll encourage Tom to respond on the mailing list anyway, for everyone's sake. All right. So next, thank you.
Hello, everyone. This is Bing Liu presenting limit domains and internet protocol. This is new work that presented in last IETF by my co-author, Brian Carpenter. And we got some interest and got some very useful feedback. So this time some update. Okay, this is some example of what the limit domains in the actual network and what's the corresponding technology. But we know that it's not a one-to-one mapping. They are two separate lists. Just show some examples. Okay, since last IETF, we got some useful feedback, and then we reorganize the text, and we add some taxonomy to make the problem space to be more comprehensive. And we also add two sections to discuss the scope of protocols and functional requirements for limit domains. For the taxonomy, first of all, for the domain, why it should exist and what technology it is used. It's a L2 network or L3 network. It's a geographic locality, or it's a kind of overlay drawn together through a public internet. So that's something we need to define for the domain itself. Then for the nodes, we also want to define the node, whether it's security enrollment and whether the node is belong to one domain or multiple domains, etc. And we definitely need to define the domain boundary explicitly, and also the topology, etc. So it's not yet a complete list. So we also expect your input. Okay, for the scope of the limit domains, as we know that it has always been protocols or mechanisms are actually designed and operated within some explicit or maybe implicit domains, rather than a real end-to-end across the universal internet. So this is happening, and the trend seems like more and more technologies are really belong to limited domains. So our basic goal of this work is to whether we can come up with some common requirements and common considerations so that it is actually a challenge to the current notion that every internet protocol is defined in the scope of universal interoperability. So that's the bottom line. And we want to hear opinions from you, whether you agree with the trend and whether you agree with the principle. And there's some new work as the draft shows in the IP layer. It explicitly defines some domains to be operated. So with a functional requirement, first of all, we need to assign a domain an identity so that every node and every protocol can explicitly knows about the existence of a domain. And then the node eligibility, the node have to determine by itself, which domain it will join. And when the node join the domain, we must provide a kind of secure enrollment. And the domain, the node can also withdraw the joinment to a specific domain. And we should also allow the node to temporarily join the domain. And yes, Eric?
Yeah, can you go back on the previous slide, Eric Vink? Maybe I missed the concept of domain, but when I see the requirement to join a domain, that could be simply my old laptop connected over an Ethernet cable to my new laptop. I don't think this, I think it's a bit too complex. Or did I miss completely the domain definition?
Yes, the limited domain defined in this draft basically several basic scheme. One is just a geographical or physical locality. And they may be standalone, and then they may be connected to the internet, but they operate some functions only within their scope. That's one kind. The other is logical limited domains. They may be distributed among a very much wider area, but drawn together through VPN kind of technologies. Yeah, that's basically two modules. So for your case, if your laptop connect to your home or your office from here, I think they can categorize into the latter one.
Okay, that's for sure. If you have something which is more distributed, I agree with this. That's no problem. But if you have some domains that are really next to each other, or if in my, I mean, it may be a little bit of an overkill. That's only my point in some domain. And that's it.
Okay, thanks. That's surely something we need to consider to make the definition more comprehensive. Yeah. David? Okay. And we need to define the role within the domain. The role indicates what authorization a node has and what capability. And also we need a verified peer, a verified role, and last we need some domain data. Yeah, so this work is still at a very preliminary stage, and we now just sort out some very general requirement and considerations. So we expect your input to dig into in more details. Yeah, David.
David Black. So I have a number of scars from living through, as mentioned, adventures in transport that eventually resulted in us defining the notion of controlled environment. Anybody wants to look for that, see the UDP guidelines RFC, which I believe is 8085. Trying to figure out how controlled environment relates to limited domain, and particularly with all of the security requirements you have around enrollment. It sounds like you're asserting that the moment I get away from geographically isolated, that you're thinking about an overlay domain where the nodes are scattered here, there, and everywhere, and somehow have to associate with each other. For controlled environment, we wound up leaning heavily, in many cases in practice, on the notion of common network operations and administration. In some sense, you could think of this as dividing up the internet by AS, and there are certain protocols that you simply don't want to operate beyond a single AS. I'm not quite sure how this relates to what you're doing here.
Yeah, personally, I believe the controlled environment definitely has some overlap, or maybe a very big overlap with the limited domains. I don't know the controlled environment very much in detail, but for limited domain, this draft for the terminology, I think the essential point is that maybe we need some explicit definition and explicit regulations of operation, and that might be expressed as kind of options or metadata in the protocol, rather than the current model that it is always be done out of band by a human's management.
Yeah,
I think that's my understanding so far.
Okay. I think I want to agree with you that sorting out the relationship and overlap between limited domain and controlled environment is an important thing for this draft to do going forward, and I will find a way to help.
Okay, thanks.
Eric Klein. I'm not really sure philosophically I agree. This seems like a way to get exemptions for things that people will tell you are bad ideas. And then you say, oh, but it doesn't harm the internet, therefore it's a limited domain, therefore we can do whatever we want. And sometimes things jump domains, you know, sometimes things connect to multiple domains, and even if it's not like physical things, sometimes standards can jump domains, things that are applicable, and right? So, you know, like philosophically. So I don't really think I really agree with what I think this is actually trying to achieve.
So did you mean that, okay, let me ask a question. So do you agree that more and more functional protocols has a trend, they only operate within the scope rather than pure, you know, universal scope? Yeah,
I mean, not really.
No,
There's a lot of reuse of internet code, and you're now going to say if this limited domain then behave this way, if this other limited domain then behave this other way. This sounds like a recipe for complexity, actually.
David Black, doesn't have to be both scenarios. We've in fact in controlled environment done it both ways. The two poster children for controlled environment are MPLS over UDP, which thou shalt run in a controlled environment, because otherwise heaven help you with misbehavior of the MPLS forwarding plane. And GRE over UDP, which actually is an example that we spec twice and has different constraints on it depending on whether you're in a controlled environment or not. We absolutely positively needed the concept of controlled environments to get those protocols done. We could not have gotten them done without that concept.
That sounds like administrative domain or cooperating administrative domains, conceptually.
Yes, and yes, controlled environment for those two protocols maps very strongly onto administrative domain, and in particular appeals to awake and aware network administration to catch things that may go wrong when we allow the relaxed operating parameters in a controlled environment. Somebody's got to be paying attention.
If this isn't exactly that, then this is a superset, I think. But this limited domains concept that they're trying to define. I understand doing things in a cooperating, in a single administrative domain.
I'm going to agree that there's a relationship. I'm going to defer on trying to figure out whether it's superset, subset, overlap, or whatever.
Hi, Suresh Krishnan. So I have read the draft, and I do think this is a conversation that's not limited to this working group. I just don't know like a good venue for this, but I think it's something that we need to talk about at the IETF level. I don't think it's really limited to something we can do here. So I think it requires a wider audience. And I don't know where it is. Like, is this a non-working group forming BOF maybe next meeting or something like that? I do think we need more eyeballs on this because I think it strongly affects like pretty much all the areas. So because I think I could apply this to IoT domains, for example, that like, people do different things, and like transport, like David said, like routing too, right? Like, some people say, hey, we don't need security for routing, right? And like, hey, it's administrative domain. So that kind of thing kind of like, probably has to be looked over at a higher level than here.
Thank you. Personally, I think it's also strongly relevant to ops area, at least. Thanks.
Rüdiger Volk. All the examples brought up here at the mic were at essentially low network layers. Of course, such limitations may happen at other layers. And I think that is kind of a wide field, and I'm not sure whether there is any way of controlling that.
Yeah, I think the bottom line is this work is not preaching the limit domains to be a mainstream or not, but the work is based on some fact in the internet, and we need to consider it seriously and to see whether there are some extra work needed to be done. Yeah.
Are you giving any examples of what you are seeing as the trend of what you're concerned about?
There are some examples, but might not be sufficient to prove this is a trend or not. But there are some examples. You can read the draft. It's about to insert some header for segment routing explicitly within domains rather than end-to-end. This is just an example. I cannot prove the trend is happening. I think people might have different opinions. That's okay. We can discuss on it.
The hints that I'm hearing seem to be like, yes, if you have a well-structured systems, there are infinite number of ways of kind of breaking the structure, and controlling people to break the existing structure obviously is hard. So yes, if one just allows people in the wild to do whatever they think they should do to the systems, of course you get a trend like this. But that's a trend that you do not want to support.
Mm-hmm. Mm-hmm. Okay, I understand the controversy, so we need more discussion. Yeah.
Okay.
Thank you.
Thanks. So next is Jing.
Hello, can you hear me?
Yes.
Okay. All right. Yeah. So this is about the MEMS work that we are doing together with a few folks. The MEMS stand for Multi-Access Management Services. And here we are present the latest draft that we are working on, the user plane protocols. And the draft is -06. And this is actually the first presentation we did in this group, but we did a lot of work offline, improving the draft, working with other folks. So next slide. So a little bit word about the reference architecture for MEMS. So MEMS is mainly for managing the multiple access. It introduces two functionality or logical blocks in the network and the client. For the user plane, the network multi-access data proxy handles user plane functionalities in the network, and then the client multi-access data proxy handles the user plane functionalities in the client. And the user plane protocol is basically the protocol runs between the NMADP and the CMADP. And that's the main focus of this draft. Yeah, next slide. Just list the user plane related requirements from this framework reference draft. Basically, we like to have access technology agnostic solutions, meaning that it has to be a layer 3 or above. And then it has to support the common transport, meaning that maybe there is a mailbox deploy on the path. It should have the independent access path selection for the uplink and downlink, meaning that we may want to steer traffic over different access for the downlink traffic and uplink traffic. One example could be that you have a TCP flow or TCP sessions, and you may want to send a downlink TCP traffic over one access and then uplink TCP traffic on the other access. And we want to be able to adaptively switching the path for different between different access, and also be able to aggregate just like multi-pass TCP, utilizing multiple access to improve the end-to-end throughput. And when we switch from one pass to the other pass, we like to be able to provide a reliability during the switching. And then because of different network paths may have different MTU, and because of different tunneling overhead, we may need to support fragmentation, and also potentially a concatenation could be also a very nice feature, especially when we have many small packets, then maybe we can concatenate them to transport. So efficiency. So some requirements are listed here, but for details, you can actually check the framework document. Next slide. So for the user plane, for the MEMS, really we divided into two sublayers to attack this problem, to address the issues. The first layer we call a convergence layer, and this layer address a sublayer. We address the task across multiple access. For example, the path selection, aggregation, and reordering, and lossless switching. In this sublayer, we have defined 3 solutions that is available. At least we tend to include in this framework. The first one is a multi-pass TCP proxy, which is basically reusing existing protocol that has been developing IETF community. The second one is, this one is basically layer 4 solutions. And the second one, third one is layer 3 solutions. The third one is the GRE-based protocol. And then basically we are reusing the GRE encapsulation, but we carry additional information in order to support the MEMS functions. And then the last one is a completely new function protocols. We call trailer-based convergence protocols. Compared to GRE, it is because it's new, so we have the flexibility to support more functionalities, as well as remove some limitation of GRE. For example, GRE require IP over IP tunneling. So with trailer, we can get rid of the tunneling overhead. And then the second layer or the second sublayer is adaptation sublayer. This layer addressing all the access-specific constraint. For example, if we need to support security, tunneling, or traversing over the net, we have right now defined 4 different methods we can use: UDP tunneling and IPsec tunneling. And then we can also use a non-tunnel based approach, where if you want to send packets over access without tunneling, you can do one also pass through without any changes, the IP header. The other one is to just change the IP source IP address to a specific IP address that is corresponding to the access. So we call client net address translation. Again, this is not a complete list. I mean, we definitely welcome the inputs and to expand, because there's many tunneling mechanisms out there that we can use. I mean, in this layer, we tend to reuse existing mechanisms instead of develop new ones, because we believe there's already sufficient solution out there. Yeah. All right, next slide. Next slide. Hello? Can you hear me?
Yeah, switching slides.
Oh, okay. Oh, actually, I think right now it's a slide 6. Can we go back to slides 5? Yeah. Okay, great. Thanks. So first, so now the rest of presentation is focused on the convergence layer. So in convergence layer, we have the first option, multipass TCP. This is a stack. Basically, you can see that we have this multipass TCP layer that's kind of operate as a convergence layer, and then we have the TCP subflows. And the good thing about multipass TCP is a basic mature technology, maturity protocols. There's real world deployments. The limitation though is that it's only supporting a TCP traffic. We also see that lots of web traffic today is actually start using QUIC and UDP based. Then you probably need to develop also multipass QUIC to support this kind of multi-access convergence functions. So layer 4 has this kind of limitation, which is more like specific to a traffic. And also the limitation in a multipass TCP is that for individual TCP, both downlink, uplink, always using the same access. There's really no way to separate them on different access based on the independent selection of the access for downlink and uplink. So that's the first option. No change to the protocol. We can just reuse it in MEMS framework. The second, the next one, next slide. So second one is based on GRE. Again, we are using the existing encapsulation protocol, GRE. As you can see here, it's composed 2 layers. The first one is a GRE encapsulation, and then there's the delivery protocol headers. The good thing, the benefits of GRE is it's a layer 3 solutions. Now we can implement all the convergence functions for independent of the transport layer protocols, right? So basically, it can support both TCP and UDP. The limitation though is kind of require always IP over IP encapsulation. And also because of GRE header is already defined, so we kind of reuse the field, some field there, for example, the key field, to carry the MEMS specific information. So that's the that is the second option. And next slide.
Yeah, please keep going so that we can wrap it up in the next couple of minutes.
Okay. Yeah, the slides. So basically, in this one, the last one is a trailer based. So this one is a new protocol we're proposing. And the main difference here is we get rid of the IP over IP tunneling, and we add the control information at the end of the packet. And then we have this IP protocol type to use. Either we can define a new protocol type to indicate the presence of trailer, or we can use the 114, which is kind of any zero hop protocol, generic type that we can use in this case. Of course, our preference would be if we can define a new prototype, then we can work together to refine the format of the payload. Sorry, the trailer format to support this kind of various operation. The benefit is it's a low overhead, has a high flexibility, support all traffic, just like the GRE. But it does require a new protocol to be defined. Okay, so next one.
Is there a question?
Yeah, so there's question. So I'm just trying to understand, like, what's your end goal in doing this, right? Because the framework document itself has been submitted through the independent submission stream for publication. Okay, so are you planning to bring this to the IETF to do this work, or like I'm just trying to find out like where you're heading with this?
Yeah.
Protocol bits.
Great. So thanks. Yeah, so I think the framework is going. I mean, I work with also Satish on the framework side. So that one going independent. But I think this one, because it does introduce new protocols, we do like to bring this into a working group and work with the community to actually introduce and try to refine this specific convergence layer, how we defined it. Yeah.
Right, and one of the issues I have again with that is like similar to GU. There's like quite a large body of work to be done here. So like if I look at the MAMS framework, it's like a huge document with a lot of things in there. So as I said, this is not the home for that, right? So like if you think that's like you want to pursue your IETF work, like, you know, come to me, talk to me for a BOF, or talk to any AD for a BOF, because this is not like a one-off item for sure. Right, like I seen them. I read the MAMS draft, like the framework draft. I was the shepherding AD for the conflict review, so I know like the scope of the thing, and it's pretty big, huge, if I may say so. Right, so it's like, yeah. So let's talk about it. Like, you know, quickly go through this to, like, you know, summarize. But we should talk about the future of this draft somewhere.
Yes. And actually, one thing that I do want to mention is that the convergence layer that we are defining this is not just limited to MAMS. MAMS is a framework that uses multiple protocol solutions out there, right? So I think in this draft, we actually introduce a new convergence protocol. So this one can have broad impact other than just MAMS. So that's why I think it worth to explore how we can work together in IETF community to actually further improve this. Just to summarize this, okay, so MAMS is a framework that we know that's managing different convergence solutions. And in this draft, we actually list various convergence solutions, multi-path TCP, GRE-based, and specifically, we propose a new trailer-based convergence protocol. It has a low overhead, high flexibility, and it shares similar encapsulation approach as the IPsec ESP to be more generic. And yes, I think the next step is really to explore what would be the opportunity, how we can bring this to IETF and work further on this one. Yeah, thanks.
Excellent. Thanks a lot, John.
Thank you.
Okay, so next one. Jizu.
Hello, this is Yizhou. I'm going to present this overlaid path segment. Actually, we have presented in the transport area working group. I believe quite a number of work actually belonging to the transport area, but we want to present here, want to bring some attention in the internet area. This is because we kind of think eventually some of the encapsulations could be done. So it's something like call for interest or call for expert to, for your attention. And so the motivation here is actually pretty straightforward. There are quite a number of researchers and even some deployments trying to leverage the cloud router nodes in various clouds to establish a better path in order to provide the performance closer to the list lines. So we also ran some of the experiments by ourselves. Then we find out actually quite a high chance, the 71% chance we can find a better overlay path compared to the default one. So now this kind of approach is becoming more and more practical for various reasons, like it's becoming more inexpensive than the NFV-based. This thing is easily scaling, and quite a number of cloud providers can provide the enhanced network performance instances. They give better PPS forwarding capabilities. So I roughly showed some of the experiments here. We create 120 overlay nodes. I mean, in different clouds. Then this is part of them. So what we want to show is actually the default path is not always promising. Some of them are really good, but some of them, let's see, the red circles, actually it constantly give the bad path latency. Then this shows we measure regarding the packet loss. So some of the paths actually almost always give the high loss rate. Actually, this is one is Bangkok. And for some other paths, sometimes it's good, sometimes it's not so good. So what we are trying to do is, actually this problem is quite well known for a while. So the slow loss recovery over long haul network. So for some certain applications, and especially for the intercontinental networks, the end-to-end packet loss recovery is not good enough to meet the requirements. So potential methods is the local recovery, either retransmission or doing something like replication, the fact thing. So why we want to bring it up now, as mentioned just now, the cloud internet allows us to do the path selection, and it naturally has already been broken, partitioned into multiple path segments. We can manipulate these overlay nodes. In some emerging technologies like virtual I/O gives them more forwarding capabilities. And the second problem is we know the TCP sender actually decreases its sending rate normally by a fixed ratio whenever there is a packet loss is perceived. So basically it's because sender has not much information available to determine how much to decrease otherwise. So there's some researchers on this. In this particular scenario, actually the overlay nodes could provide more richer information, like the loss information and the congestion information to the sender, so to let the sender better decide whether it wants to decrease the sending rate or how much to decrease. So these are the second problem. We want to take these opportunities to do loops, which is localized optimization on path segment. Here, the localized actually may not be so accurate because the local means the between two overlay nodes, but physically it could be far apart. So to address the problems we mentioned just now, and also to address the problem that the overlay nodes normally they have limited capacity, and in case of the impairment of the hop of the link between overlay nodes, then how we should fix that. Now, briefly, we figure out there may have three key elements of a solution. The first one is a local recovery over the tunnel. And for sure, we would require the loss detection and indication, and measure the segment RTD. And if the retransmission is required, then the attempts has to be limited. And if the FAC is to be used, then we need to control the intensity. The second key element is a congestion control interaction. Certainly, we don't want to compete with the upper layer end-to-end session. So possibly we need to export some congestion control signal to the end-to-end transport and support the ECM. And the third one is to do the traffic splitting and recombining to overcome the limited capacity of overlay nodes issue. And also, if we want to do the multiple path segment FAC, then we want to decide how to do this. So basically, we kind of think that some common elements are required for local recovery and traffic splitting. We are trying to figure out a feasible way to interact with upper layer for congestion control. So the third bullet actually possibly more relevant to the internet area, the overlay protocol extensions. We haven't figured out a feasible way to work on it. We haven't gone so far yet. So this is just to bring some attention from, to the internet area. So the comments are welcome. Yeah.
Thank you very much. Are there any comments? All right. No.
Okay.
Okay, thanks. So next is Vlad.
Eric, then just a small comment of you. Oh, go on, it's very short. If you name this with an acronym which looks so much as OSPF, this will be quite confusing, but it's cosmetic.
Good point.
Right, so I'm going to give you an update on our latest work on the SOX protocol. So we've got 3 major changes in version 5 of the draft. First up, we're going to change the way we handle the first bytes of the application data. We've also improved the reverse TCP proxy functionality. So now you can process. So now the client can receive multiple incoming connections and process them in parallel, even if all of the incoming connections are to the same port. And also, we've also revamped the UDP behavior. So the UDP behavior in SOX version 5 was problematic, and I hope we've fixed it. So first up, false starts. So the basic premise of this is that the core state machine is pretty simple. So the client sends a request, and the proxy has 2 chances to say no. First up, it gets the chance to say no because it doesn't trust who the client is, and then it gets the chance to say no because the connection failed. Now, complicating this state machine is only possible if the client signals that it wishes to do so. So in this case, if the client includes an authentication method option as part of the request, then it can do the classic authentication as is done in SOX version 5. So the basic idea behind false start is that the client can start sending application data as soon as possible, as long as it doesn't risk breaking the state machine. What that basically means is that it can send data right after the request if it's not willing to go through an authentication phase, or if it's willing to do an authentication phase but 0RT authentication succeeded, then it can send application data as soon as it receives the first authentication reply signaling success. Or if it goes ahead and goes through the authentication phase, it can start sending data right after the last message it sends out during the authentication sequence. This, of course, depends on the authentication method used. Now, given that false starts are not only possible but outright recommended by the draft, the concept of initial data doesn't really serve any purpose unless the client is willing to go through the authentication phase. So the initial data length field was moved from the request. It is no longer a core feature. It has been moved to the authentication method option. Now, initial data length, we've kept initial data length at 16 kilobytes, and it can no longer be dropped by the proxy. Now, 16 kilobytes is a reasonably small number, and it's in fact smaller than typical kernel buffer sizes used by TCP stacks. So there wasn't much point in allowing and giving the proxy a chance to drop that initial data. So it can no longer drop it. So, and as such, we've removed the initial data offset from the operation reply. Next up, we've added a payload length field to the TFO option. Now, when the proxy does TFO on behalf of the client, the problems can arise if it sends too much data or too little data. So the the TFO since payload is covered by different semantics. It has different guarantees, and as such, the client should be able to signal how much data it can tolerate being replayed. Now, there's also a corner case in which, if the payload is too small, bad things happen in terms of timing. Let me show you what I mean. So let's say the client sends out a request, and it also tries to do an HTTP GET. Now, for some reason, the HTTP GET gets fragmented, either because the request is too large and it didn't fit in the SYN's payload, or some middle box dropped part of the payload. The proxy immediately sends an HTTP GET to the server. Now, assuming that there's high RTT between the proxy and the server, and low RTT between the client and the proxy, the client can send the rest of the GET request relatively quickly, but the proxy's hands are tied until it gets the SYN-ACK from the server. And only after it receives the SYN-ACK can it send the rest of the HTTP request. Ideally, the client should be able to tell the proxy how much data it expects to be part of the SYN's payload, so that the proxy delays sending the TFO SYN over to the server. Next up, TCP reverse proxy. So the bind command works as follows. The client sends a bind request to the server, to the proxy. The proxy listens and accepts one incoming connection, and then closes the listening socket, and then relays the data from the connection through the connection initiated by the client. Now, we would like to emulate typical server behavior. That is, we want the proxy to listen and then keep accepting multiple connections on behalf of the client. So we do that. So if the client wishes to do that, it can include a listen backlog option as part of the bind request. This prompts the proxy to listen for as long as the connection is open. Now, that first connection no longer relays data from an accepted connection. Next, the proxy issues further bind requests, and each bind request will basically translate into an accept at the proxy's end. Now, needless to say, this is only for authenticated clients, because we don't want a client accepting connections from a socket that was bound by some other client. And finally, we've revamped the UDP relay behavior. We now have DTLS support, and it is a lot more firewall friendly. So we no longer have the client send UDP datagrams to arbitrary ports. We use one port, 180 by default, and the DTLS port is still to be allocated by IANA. So now UDP relaying works as follows. The client issues a request over TCP, telling the proxy what bind address and port it wishes to use. Of course, it can use 0 if it doesn't know or doesn't care what address or what port it receives. The operation reply tells the client what bind address and port it has received, and the proxy sends one further message called an association initialization message that tells the client what association ID it has been allocated for that particular UDP association. So next up, the client sends a UDP datagram. Now, the first UDP datagram, the client can send the UDP datagram either over vanilla UDP or over DTLS. When the proxy receives this datagram, it sends an association confirmation over TCP. And from that point on, the association ID is forever bound to the UDP or DTLS conversation that the first UDP datagram was sent over. Now, this association confirmation message helps the client resend lets the client know that the first UDP datagram has been received, and in cases where the client wishes to run a server, it can just keep resending that datagram until it receives an association confirmation. After the association confirmation, UDP traffic can flow in both directions. Now, without further ado, this is the datagram header that all datagrams flowing between the client and the proxy are prefixed with. We've got the source version, the association ID, the address, and the port. This is pretty straightforward. We've made a few more small changes. So we've added a stack option whereby the client can signal what what the IPTOS field should be. This is obviously useful for voice over IP or other protocols running over UDP. We've moved any remaining idempotence options from operation replies over to authentication replies. There was a slight oversight in draft 3, which allowed multiple authentication phases to take place. That was not intended and has been fixed. And we removed TF options from your operation replies because we couldn't find any use case for them. There is an implementation available. This is version 05 of the draft, but the implementation complies with version 04. We've got a message library, a utility library, and also a proxifier, a transparent proxifier and a proxy. It's all available on GitHub under a very permissive license. So what's next? I've been talking to the Tor guys, and it turns out that they have a new use case for me. So they've been making use of the username field in order to signal to the proxy what Tor relay should be used. That's a very hackish use of the username and the password. It would be nice to add some functionality to cater to them. So I've been toying with the idea of introducing versions to socks. Versions have been the concepts of the versions have been part of socks on the form of another ever since I introduced the idempotence options. Now I'm going to make it explicit and allow authenticated clients to have multiple sessions, thus allowing multiple clients use the same credentials yet have different session state associated with them as the proxy. And that's about it for me.
Okay. Thanks, Vlad.
Suresh Krishnan. So, what are your thoughts on how you want to progress this? Do you want to take it here? Do you want me to pick it up as AD sponsored, or what do you want to do with this?
So I want to standardize it. I am not sure about the exact process, but I'd like to standardize it.
Okay, cool. Thanks. Okay, so come talk to me. We'll figure out what exactly to do.
Sure.
Okay. Thanks.
Great. Excellent. So thanks very much. That's pretty much the end of our session. So see you next time in Prague.
You have to do like this to it and like twiddle it around. Should be.